Hello everyone, welcome to the OpenAGI Forum. I'm Wei Lu from CSDN, and today live from GoSing Conference Europe in Delft, Netherlands. We are honored to have Jonathan Kelly from Dioxus lab based in San Francisco. He's got plenty of legendary stories to share. Welcome, Jonathan.
Great, thank you for having me.
Could you briefly introduce yourself to our audience first?
Yeah, my name is Jonathan Kelly. I'm the creator of Dioxus, which is a popular Rust framework for building apps cross-platform. Before Dioxus, I worked at Cloudflare, and then before that, actually NASA Langley Research Center.
Yeah, just could you share how you're interested in technology and programming, how your interest started, and how Dioxus started, and why you choose Rust? You can talk it one by one.
Yeah. So, I mean, my interest in programming started when I was a very young boy. In my area, we had like the first Lego League, so you could program the little Mindstorms robots. You could build them with Legos, which I loved to do as a kid. So it was like a natural evolution. That was all LabVIEW to begin with, like a drag and drop programming language. But then eventually I picked up C, C++. I did a lot of physics simulations, so I worked at NASA for a little bit, so there's some physics in there. And then I eventually got into Rust. Rust is so fast, it's so performant, and it's really good for actually high performance physics simulations. And then from there, I got into building apps with Rust. So.
As of now, Dioxus has gained significant influence among developers with nearly 20,000 stars on GitHub. Could you share your experience in launching and managing a successful open source project?
Yeah, so I never expected Dioxus to get like 20,000 stars on GitHub and be as popular as it was. For me, it was just a passion project that I did on the side during the summer when everybody was indoors. I published it, and then in a weekend, it got really popular. So in almost 2-3 days, it hit 3,000 stars on GitHub. So I had a very meteoric release, which was great. Since then, it's been almost 2 years since we put out into the public. We've been able to do things like the GitHub Accelerator, so we've been able to work alongside other really cool projects and build Dioxus full time. And then now we're a startup, so I'm based out of San Francisco, and we raised some venture capital to actually turn it into a company.
Okay, so it's just a side project at the beginning.
Yeah. I mean, I'm a big tinkerer. I love to take an idea and then play with it a little bit and then put it out into the world and see if people like it. Not everything I do is hyper successful. Some stuff is just cool, but not interesting. But Dioxus is one of those things that really took off. Yeah.
So what most special about Rust, as you mentioned, the first is the speed, and any other special points comparing to other languages or other tools?
Yeah, so I mean, my background was in physics, so I would write a lot of Python. We had a lot of Python simulations. Getting Python up and running can be challenging sometimes. I think I spent more time trying to figure out my Python installation than I have anything in Rust. Rust is like a difficult language, but it unlocks a lot more interesting projects you can do with it. So a Dioxus app, for instance, can run on a small little Raspberry Pi, or you can put it on a supercomputing cluster, or you can do AI stuff with it. I mean, Rust is extremely flexible in a way that every other language, they are good at a certain bunch of tasks, but they can't do everything. Rust is a little bit harder to learn, but it seems like it can do everything. Maybe not that well, maybe it's not that easy to write, and we're working on it.
The flexibility to run any kind of, and as we remember, Java also claims to be run anywhere, but it's slow and not that flexible.
Yeah.
Okay. And your topic about on today is AI related.
Yes.
Could you briefly introduce a little bit?
Yeah. So we built a version of Llama. So we fine-tuned Llama, and we fine-tuned a model called Phi. So which is like the new Microsoft coding specific AI model. And we actually fine-tuned that for Dioxus code. So there's not a lot of projects, if any, out there that have a large language model tuned exactly to that project. So our LLM can do all sorts of cool things. It can write code for you to do like components. So if you wanted a new, like a blog component or a portfolio component, it's very easy to prompt and you get perfect Dioxus code. We generate a bunch of synthetic data, we threw in our own projects into it. So it can create components and it can also test components. So we have an agent mode for the LLM. It can actually walk your site and give you feedback on the app that you've built. So things like layout or accessibility or style, it can like analyze for you, tell you if you're doing a good job or a bad job. And coming soon is the ability to actually create a pull request that fixes those things. So as you're building your app, the agent can actually go and fix all the bugs that you've created.
Yeah, impressive.
Yeah.
Actually, what I'm also doing is kind of LLM or AI assistant coding. So roughly how many tokens of the Dioxus code base you use to fine-tune the Llama?
Yeah, so what's interesting is we don't have a lot of Dioxus code, if not millions of components, right? There's maybe 20 to 30,000 public components that people have written. And then we don't know if those components are good or bad. So we actually decided to create a synthetic data set, which is what our talk is mostly about, is like how do you build a really good synthetic data set? Yeah. Doing that, so we generated maybe like 100,000 prompts, and then we whittled down to maybe like 10,000 really good prompts. And those prompts are maybe 500 to 2,000 tokens. It depends on the prompt. We tried to do some prompt compression to make that smaller because the models actually run locally on your machine. You don't need to run them in the cloud.
How large is the model you are using?
Yeah, so we fine-tuned 2 models. If you have a bigger machine, you can use the Llama 8B, like the, that produces a lot better output than the Phi model, but it also requires like 5-6 gigabytes of VRAM on the GPU, and not every laptop has that. If you have a smaller machine or a more portable device, we have the Phi 3 model fine-tuned as well, yeah. Okay. And that's like 2 gigabytes of VRAM when it's like quantized.
How do you feel, for example, with such a small amount, relatively small amount of data, people suggest not fine-tuning but use RAG or other solutions. Could you compare have you ever tried to compare the performance of fine-tuning and RAG? Yeah,
so I mean, there's obviously a lot of ways. And some of these models have really large context windows. We found that we could create a really good synthetic data set, mostly because Dioxus uses HTML, like its main syntax is HTML. So we're able to rely on a very large corpus of data that these models have already been trained on. So we really only just need to tweak them a little bit to get a lot of the same benefits. I think we would need a much larger data set, way more Dioxus components that the model could generate. Since we're using HTML as like the seed, it's pretty straightforward just to do a fine tune and then convert those HTML tokens into Dioxus tokens, because there's a pretty close mapping between the two.
Okay. Dioxus used Rust also?
Yes, yeah.
Yes. And have you ever tried to, I'm not sure, Python is the native language, kind of native language for LLM, and Java or JavaScript performs a bit worse than Python, but pretty good than others. How about Rust without special fine-tuning? How the Llama perform on Rust?
Yeah, so the large language models aren't great at generating Rust code. We're fortunate that we are close to React, so we can actually do some translation of React code, like an on-click handler. We're able to loosely convert from JavaScript to Rust. So it's not perfect at doing that conversion, but most UI code is pretty simple, so you don't need anything too complicated. Our AI is also written in, like the inference engine is a Rust engine. We use something called structured generation with constraints generation, and all of that uses Rust in there, so it's like still pretty performant.
Okay. Because we also try to improve the performance of Llama or other LLMs to make it better on C++ or some other specific languages.
Yeah.
I think that's not easy task to make it as best as the performance as well as Python.
Yeah.
Yeah, I think it is a good topic.
Yeah.
How to make the democracy of languages for code LLM.
I think something that is useful, I mean, we're interested in exploring, you were talking about RAG, like retrieval, in your talk.
Yes.
We have been toying with the idea of maybe you could actually use the type system of Rust, like the language server, in generating that synthetic data set, mostly to like very much limit the search space of tokens, right?
Yes.
A struct or a class only has a couple methods on it. And if you do a fine tune or you modify the weights in a way, you change the way you're handling tokens, you do structure generation, there's only so many valid methods on a struct, and it's a lot faster to do that. And in theory, it's higher quality. Now, Rust is more complicated than Python.
Yes, yes.
Yeah. Fortunately, UI code is pretty simple. And what we're mostly generating is HTML. And HTML is not like a Turing-complete language. So HTML is way simpler to generate than good C++.
Yeah. So when we talk about the synthetic data, what model you use to synthesize the data? Very powerful, like GPT-4 or?
So the Llama model is pretty good. The most recently released, the open source meta. So we used Llama 70B to do the
Llama 70B. Okay.
Yeah.
The Llama 370.
Yeah, the Llama 370B.
Is powerful enough for your case to generate data.
Yeah, I mean it's pretty close to GPT-4 in terms of performance, like its reasoning engine, and we were able to run it on Grok, which is way more performant than like the ChatGPT, like the GPT line of models. Grok is really fast.
Yes.
So that was a very like interesting shortcut. And it was basically free to train or free to do the fine tuning. I mean, maybe like $5 to $10, but we have credits and stuff. So yeah.
So when you start a Dioxus project, have you ever planned this kind of AI functionalities from the very beginning or in the later years?
Yeah, I mean, no. 2 years ago, like AI.
Yeah, because you know in 2023 everything's has changed.
Obviously, we've had the idea of making it easier to build, widgets and UI and stuff. And there's a lot of like drag and drop designers, things like Figma. Maybe not Figma exactly. Figma doesn't export Dioxus components, but we've had that idea for a while. But this AI, generative large language models, and especially the fact that they can run locally and they're more performant, really just opens up an entire world of applications we didn't even know were possible like a year ago.
Yeah. So for now, are you involving the AI guys, researchers, or professors or PhDs, or your programmer learn to do the AI stuff?
Our programmers, well, I mean, our head of AI wrote an AI meta framework for Rust. It's called Colosm, and it does a whole bunch of cool stuff. So you can run large language models locally on your machine. It has OCR, so it can like take pictures and like see what's in them. It can do speech to text, so whisper. So it does a lot of stuff. And in building that project, he gained a lot of experience in large language models. So it really does seem like something you can just break into. The more we get into it, obviously more math pops out. So we're getting lower into the weeds of these models and we need more knowledge. But so far we haven't needed a PhD to ship what we want to ship.
Okay.
Yeah.
Yeah, because in some of our projects, you have the AI guys and you have the coding guys. It's a little bit kind of an integration problems, because sometimes they are thinking in a different way. Yeah,
for sure. I mean, our constrained generation is a very important feature of the LLM that we've built. It takes the performance of the model, the accuracy of the prompt outputs from 20% to 90%. And that's like an engineering problem. That's not necessarily a math problem. And we're trying to find all of the wins we can get by good engineering before having to like reinvent any math.
And I've seen that you have some Chinese developers in your projects.
Yeah.
Do you have any feeling about, is there any difference of Western developer or Chinese developer?
I mean, I was definitely surprised. The project is very international when you look at who's downloading it, the contributors. We get a lot of great contributions from the Chinese community. People are very enthusiastic to do translations as well, which, I mean, I only know English, but it's great that people are excited to bring Dioxus to like a broader audience. Honestly, we just see like enthusiasm from everyone, which is great. People are adding new features, component libraries. Yeah, I mean, I love the fact that it's an international project and it's not just a USA thing, right? We have people everywhere.
And you have developers from Europe?
Yeah. I mean, we have people from New Zealand all the way to Spain, to China, to Japan. I mean, it definitely seems there's a lot of interest in China. There's a lot of different devices, I guess, right? There's lots of different devices, lots of different screens, and people aren't so loyal to MacBook Pros and iOS and all that sort of stuff, right? There's a lot more platform variety, and in that case, cross-platform is very important. I know in the US people either do React Native or they do Flutter sometimes, or they just like write native iOS apps, because like 70% of people have iPhones in the US.
Yeah. So in just my own personal opinion, that in America and in China, the AI topic is very, very hot, but relatively not that hot in Europe.
Yeah, it definitely seems like the Europeans that are interested in AI come to the US, in my experience. And I think it's just maybe the attitude or the culture of regulation or some fear, I guess. Yeah. I mean, obviously there's fear in the US that AI is going to take people's jobs, but at the same time, people are very excited in the engineering and developer community of what all this unlocks.
Yeah.
I don't know the attitudes in China beyond, everyone I talk to seems very enthusiastic about AI and pushing the future and all this,
Okay. So do you think in the near future, not long away, is that possible that some of your project, the work of your project can be totally automated by a model trained by yourself or is that possible?
I mean, I would love for everything to be automated.
Me too.
I mean, and we write all sorts of automation tools. When I'm in the loop for anything, when I have to actually get my hands in something, it takes my attention away from the stuff I'd like to be doing. I think some low-hanging fruit we might implement soon, some very obvious stuff is read the documentation and make sure it matches what the code is.
Yes.
We get a lot of complaints from people that a function is documented, but the documentation doesn't really match what the function, like parameters say that the function should do. And this is easy stuff that an LLM could do. So, I mean, I think that's where it starts, but it could start fixing bugs, it could start adding features. I don't know, there's a lot of potential in the space.
Yeah, why I ask this question? Because we are thinking about that most of the evaluations of LLM model is comparing to the high standard of human. Yeah, but actually, maybe it's not very typical in open source projects because everyone is able enough to participate. But in some large corporations and large enterprises, even some job is outsourced to unknown people. I don't know the team, maybe they're in China or Indian, I don't know. Yes, actually I think maybe some part of this job can already be automated by airmen already. Yeah. And I think in your Dioxus solutions, it's also this kind of way of thinking to find some easier tasks or some which can be automated by language models instead of everything has to be done by a programmer or by users. Yeah. Is that way of thinking. I think the question is that what's your vision of Dioxus project regarding the functionality and how the project is running? Do you have any vision and long-term view of this?
Yeah, I mean, I think the fact that there's so few platforms, you know, in the US, you kind of have Android and iOS, is like a symptom a little bit that there are monopolies at play, or there's just a lot of funding put towards these different frameworks and developer ecosystems. I think long-term we want to be that sort of middle ground between all of the future platforms. I mean, whether it's cars or whether it's IoT or whether it's you know, phones or augmented reality, you know, any screen of the future, we want for people to be able to ship with Dioxus, and it just works everywhere. The vendor lock-in, the platform lock-in that people have to deal with today, I think could be made a lot better if people targeted a single thing and we took care of all of the complexities and annoyances, and people sort of trusted us as that middle ground that, you know, you ship on Dioxus and we'll handle all of the annoyances of working with, say, Swift UI or the Android toolchain. That way it's like really simple. You know, you create a new app with Dioxus, you can drag your widgets together, you can use your prompt inputs to add new functionality, almost like a no-code solution, but it's generating Rust code, which is like the most robust code that you could find. And you know, long term we see a cloud offering, and your teams could iterate on an app together, live collaboration features. I mean, there's all sorts of interesting stuff we could do with Dioxus.
Yeah, that's great. Okay, I think that's all. Thank you, Jonathan, for the insightful discussion, and thank you to all the developers watching. That's all for today's interview. See you next time.